Hello, everybody. John Cassell with Syxsense. I'll be going through the console today, showing us manual patching, which I consider an on-demand patch route. We'll then look at more automated routes in which we can instead provide pre and post task events for the patching process, and not necessarily say push them, but instead include anything before and after an event takes place, as well as plenty of notification methods included. As you see, I'm simply sharing out my web browser. It is a fully cloud-based solution, nothing required to host on-premise. Machines simply get an agent installed, which allows them to check in from anywhere. And of course, would include Windows, Mac OS, and various distributions of Linux. No proprietary ports required. All machines check in over a highly secure HTTPS connection. No special firewall rules need to be supplied. For the patching process, it's quite simple. 3 questions to keep in mind whether we want to patch Windows, Mac, or Linux, including all of them within the same process. Where we want to target is based upon the asset list. What we want to perform is a selection of the patch content, whether we want to choose one patch or many, or even make dynamic and static rules as well. The third question is common for every process, and that's going to be when the process takes place. Is it an on-demand route? We can also automate in the form of a schedule, daily, weekly, monthly, as well as setting certain time limits, which we consider protected hours, and even another concept to limit duration called a maintenance window. The task list will allow us to develop these. There are many other tasks also provided, not just for patching, including software distribution, feature upgrades for any Windows workstation, discovery, and other reboot options too. Today we'll be looking at the patch deploy task, where as you see from the template, it's quite easy. The first question, as already mentioned, is going to be where we're going to target. This can be highly granular, in which we can go to the specific inventory section and pick and choose machines, containers, even organizational units, or it can make a simple selection from this screen. Whether we want to target specific organizational units from Active Directory, use our preset device groups, allowing for better change control, or an easy option just saying simply pull all devices. Dynamic rules can also be supplied as well. There are a number of predefined queries already existing with Syxsense from day one, which allow targeting based on detection status, devices requiring attention, all mainly based on industry scoring, namely CVSS risk. We can also develop our own rules, which are instead more custom, based instead on a condition editor, where we can instead say, look at all devices that don't have Chrome installed, or in general, any machine that's unhealthy that might be sitting in a certain organizational unit pertinent to our environment. For this example, we'll be deploying out to all devices. The second question allows us to now target those machines with a specific content listing. This can also be as general as saying anything, although we can also make content selections too, even down to one individual patch. We have the same static as well as dynamic options from the content listing. To briefly show that listing, this allows us, again, static groups. We're more of a legacy approach. We can still pick and choose updates beforehand, preset to then use them for the next phase. Or instead use something like a classification, where we can instead create a rule, such as one of the most common exceptions, include all updates except for Java, not having to necessarily pick and choose Java and remove it from the equation, but do it automatically. This allows for a much easier automated approach without the need to pick and choose for every single time you have a deployment. Briefly, with content between the operating systems, Windows updates are supplied by Syxsense automatically. As you can see from the listing, it's not just about the operating systems from Microsoft. There are various third-party applications already included. These get pre-vetted on release day. Supersedence is always included, so you'll always be deploying the latest and never have to worry about updates out of sequence. And detection criteria is already included. Rest assured, everything is still genuine. If anything is tampered in transit from the vendors, they will be dropped, will be notified, keeping the machine secure. Of course, all metadata for content is still supplied across all 3 operating system families, showing both the CVSS and industry risk as well as the vendor risk, knowing that, of course, they don't always correlate. For Linux and Mac, we instead defer to the package managers, whether it be the software updates table on a Mac OS device, or for various Linux distributions, showing which updates the device is already getting from its local repository, or of course, online repository. Even though these packages are coming directly from the machine when we perform detection, such as a yum update or an apt-get update, it does still allow us to pick and choose content from this screen, and the metadata will still be supplied. When packages are detected, the backend will look up to the required source, whether it be from the vendor's site or from NIST, to still supply you the severity-based info. For this example, we're going to go ahead and deploy all updates except for Java. Now we can choose different schedules as well. If we don't make any selection on this screen, it's going to kick off right now. The beauty of a manual process, we can say run on demand, don't include any type of schedule in the future. We don't want it to repeat. We just want to do it right this second. If we do instead want to choose a schedule, we can choose from the calendar, such as a start time. You'll see from the illustration below, it can start now, but it doesn't necessarily end. That would be based upon the device's status. By default, if any machines happen to miss their process, they can always check in and pick it up later. If we do want to supply protected hours, such as for workstations or laptops that might be roaming, and as well for productivity, maybe we don't want these processes to occur in the middle of the workday, we can still protect those timeframes. Another scheduled approach can be more restrictive. A maintenance window by definition is going to start and it's going to stop. The question that we have is, which window do we want to go with? Beauty of maintenance windows is they can be instead pre-configured beforehand, and they're totally unlimited for as many deviations as we require, whether it be across server environments or workstations directly, or of course separate time zones. This includes a new concept called a duration, but you can still use protected hours with it. That is, when is it going to start and when will it be forcibly stopped? Recurrence can also occur less frequently, such as in monthly intervals, or more popular option for Windows devices, specifically focused on the reference point of the second Tuesday called Patch Tuesday. When using the Patch Tuesday option, especially for a phased approach, we can develop multiple maintenance windows, again in an unlimited list, allowing us to set one phase 5 days after Patch Tuesday, or even on Patch Tuesday if we want to run it in 0 day, 10 days after for the second phase, 21 days after to ensure there's a specific amount of padding to allow our testing in between. And again, this can be for as many phases as desired. Reboots are always relevant when it comes to a patch deployment. Just know it's never forcibly rebooting unless you opt in for it. The default option is always to suppress. And this is also stamped in terms of every single piece of content when we deploy it. Reboots can be ran at separate times with a completely separate schedule and a completely separate maintenance window, limiting the amount of times that devices might get their reboot. Or if we want it to run right after, the most popular option is if required. If the machine says it needs it, then force the reboot. If it doesn't, skip it. User interface options can still be supplied if an end user is there and we want to validate with them first. Very important option to still give them some time to prepare, provide them custom messaging and logos so they trust where it's coming from, while still keeping control of the reboot. Base patch process actually allows either direction of a deployment to exist. Do we want to install updates, which is the default route, or do we want to uninstall to make sure that any problematic updates can instead be removed? Some updates don't involve an uninstall, can't be removed, such as a servicing stack, but in theory, every single patch can be attempted to remove if it's problematic. At the end of every single process, you'll be given the summary, seeing exactly what's going to occur and kick off at the time intended, and an email can always be supplied at the end of the scheduled event. No limits to how many email recipients should receive the notification. This will supply both PDF and CSV attachments, letting us know exactly where the task ended. Were some machines successful? Are we waiting on some machines that were disconnected to check in later? Or was everything complete? When we put a task into progress, the beauty of the task architecture is you can create as many as you need. Every single task tracks a separate deviation. That is, every task is a new template. Are we choosing new computers to target? Are we, of course, bare deviation, targeting servers different from workstations, knowing that we may not want to push the same updates and may not honor the same exact schedule? Every single task still supplies information in real time, providing us an update about every 5 seconds, not leaving us in the dark like a policy-based approach where we set it and forget it and just hope things work, but rather tracking each individual process down to the device view. Whether it be one machine being targeted or many, it allows us to drill into that task architecture and individually see how many updates were pre-checked, how many updates were deployed, the end result, which is actually possible to have thousands of different translation statements based on errors, so again, never leaving you in the dark in terms of where things may have ended. Also, always a good indicator to see if the device still requires a reboot if we didn't opt in. A more automated route, rather than just relying on schedules, is to instead use a policy-based format, as well as offer pre and post task events. The Cortex architecture of Syxsense is a successor to the task architecture in which it's not just about running a patch deploy or a software deploy or a scheduled reboot separately, but again, allowing a lot of events to take place within the same flow. One of the examples I'm going to show is a full automated deployment, not just against a particular operating system family, but assessing all three and allowing three separate routes. This automated patch deployment has a lot going on, but it gives us the flexibility to not necessarily have to script a sequence, but take machines based on different paths, as well as based on the value that we've asked and returned. The very first question at the beginning of this sequence, when we decide to schedule it, what operating system family or platform are we looking at? For Windows, we can see it's taking the next step, which is to assess the patch list. Run that check. Now already you can see just from me clicking this one action that we include additional results upon every single process ran. Picture every single one of these actions as being a separate task, but allowing us to then sequence them in whichever order we want. The next question can then focus on performance monitoring. In this case, more resources of the device. What is the disk threshold? If it's below 5%, do not go forward and notify us via an email. One important phase to always ask, especially not just for Windows, but other operating systems too, does the device have an outstanding reboot? For any operating system and most solutions, if it requires a reboot or configuration change, then we know the patch management is not going to be successful until that pre-necessary route has been taken. In this case, does it require a reboot? Allow it to take an option or route if the answer is yes. If not, move on. Before we get to the deployment, if the answer is yes, we then want to go ahead and perform that reboot. In this case, we can now send it down three separate paths. What was the result of the reboot prompt that we have given the end user? Success, fail, or maybe we gave them the option to cancel out. The success will then take the next step, in this case, rather than just provide a notification. And this is just one option I always like to check for. That is, if we've left other processes capable of patching the machine or automatic updates, or we have a task in the background already running, we want to check the Windows Update process. We can do the same for any other process that you want to specify. This is specific to WUSA. If it's in progress, let's not go forward because we know we're already going to have to wait in queue. If it's not in progress, we can then tell the patch deployment to take the next step. The step that I currently have highlighted is the exact same option we went through earlier with this pre-built template, although clearly we have a lot more flexibility and the ability to visualize the path that machines are going to take. Patch deployments can output in various directions too. In fact, now that we're at the very end, we can see the deployment that started with the other operating system types. If the machine was Mac, we perform, of course, another critical disk threshold. We can add other steps to this process too. If it's Linux, do the same thing. If anything happens to fail, or provide success, of course, we can include, in this case, just an email notification, but other processes as well. The customization of a Cortex workflow can easily be done in the Cortex editor. As you see, it's a full action list on the right, allowing us to view certain events and of course drag them in to the editor to the left. That is, if we have an action that's in the listing, we can drag the new action in the output of the previous action. Not just for the basic events listed earlier, like a patch install, removal, or a check, but additional events and actions such as check the firewall status, check for CPU usage if we're concerned about machines in a critical state, maybe we prefer to hold on. Do we want to check for services and processes before we take any additional route with options to make a change? Plenty of options to check resources and values on machines too, like if there's a certain file that we're looking for, and we want to make a change, maybe we don't want to go forward if we see a certain binary. Plenty of pre and post task scripting as well. Back to this route, I'd like to show another example where we can push patches out to a hypervisor. Knowing that servers do include a lot of additional options to make sure that we don't perform a certain step without taking the appropriate action first, Especially for this, being a simple, more hypervisor deployment example, we can go ahead and check to make sure, are you a hypervisor in the first place? Sure, you're a Windows Server device, but do you have the required role? Again, checking for a reboot beforehand. The resultant action is to then run a PowerShell script to snapshot and shut down my virtual machines to make sure that, of course, configuration takes place before I make another change. The success of both scripts will then take us to the next route. As you see here, the path is dependent on the first question we asked. Was a reboot necessary, yes or no? If the answer is yes, perform the pre-reboot. If the answer is no, skip the pre-reboot, still send our script, and then jump straight to the patch baseline. This example can be more complex. I've got some simple notifications about these simple processes and if they go wrong. But the overall key here is that I'm sequencing my events automatically. One piece about Cortex I haven't addressed yet is, of course, who is going to get it and how often we'd want this process to occur. We can use the same scheduling options with a Cortex workflow, on demand, on a scheduled approach such as daily, weekly, monthly, as well as the maintenance windows, all accessible back in the task architecture. We can also develop policies to perform these options more frequently, such as in an interval, and you can do these as quick as every 5 seconds. Intervals are best handled when you ask your questions first to pre-qualify should the device take the next route. So essentially, run your question as quick as every 5 seconds over and over and over, using still minimal overhead, but then again taking the next route if ever necessary, such as a certain pre-detected value being seen, we want to take the next route, and if not, skip it, move on, provide us a notification. Another such example of using Cortex, especially with regard to Linux, maybe we don't want to use the graphical interface of Cortex, but leverage its notification capability and instead develop Ansible playbooks and push those out directly. We still have additional actions such as an email approval, where even though we might be scheduling this daily, weekly, or monthly, supply us an email in our inbox first asking approve or deny. If we deny it, we'll be notified and we can open up an alert incident, which can then be tracked within the console directly. If we approve that deployment, push out the playbook. Of course, the resultant set of pushing a playbook in this case is going to be success or fail. Again, we can be notified about such event. If we want to reboot the machine right after that playbook is successful, that's okay. Once it's back up, push the playbook again, providing the same notifications, although if everything is successful in this case, close the alert incident. Other examples of Cortex for other types of configuration can include malicious process detection, again, leveraging a policy to check very frequently about something you might be interested in, killing the process, enabling other such features as quarantine to isolate the computer, and of course send a notification if necessary. As well as for configuration of any machine, like pushing out all the required software. Of course, in the order that we prefer, this is a simple example. We can throw a lot more into it to make sure if devices are successful, fail, or if we want to even notify end users before we make a change, such as we're going to deploy an Outlook connector. We prefer to close Outlook before that event takes place. We can introduce an end user interface, prompt them, make sure that they have the choice when Outlook is going to get closed. We close it for them. Once it's past that threshold, update Outlook, open it back up for them as if nothing changed. So with Syxsense, we of course offer on-demand processes easily configurable in a task for manual patching as well as for automated on a schedule. And as you see with Cortex, we can include a lot more pre and post-task events, allowing more configuration, more pre-checks, and different paths the machines may take. There's a whole lot more that we can cover in Cortex, but we'll leave it for patching for today.